Hi, I'm Joe, and today we're going to be looking at this problem. In triangle ABC above, what is the length of side AD? So we're trying to find the length of side AD, which is this side here. To begin, let's start by labeling everything we know about this triangle ABD. Since angle BDC is a right angle, we know that angle BDA is also a right angle. We know this because these two angles form a straight line, and a straight line measures 180 degrees. And now that we know these two angles to be 90 and 30 degrees, we can solve for the angle A, because the sum of the angles of a triangle is 180 degrees. So 180 minus 90 minus 30 gives us 60 degrees for the measure of angle A. Now when you look at the big triangle ABC, you'll notice that angles A and C are congruent, so we have an isosceles triangle. What this means is that the opposite sides of those angles, sides BC and AB, are congruent to each other. So since BC measures 12, AB also measures 12. Perfect. But we're still trying to find the length of side AD. So where do we go from here? You'll notice that triangle ABD is a right triangle because of this right angle, and we're given the length of the hypotenuse to be 12. We can't use Pythagorean theorem because we would need to know two sides in order to use that. Instead, the answer lies within the measures of the angles of this triangle. We have a 30, 60, 90 right triangle, and with that comes our key takeaway for this lesson. So let's take a moment now to review the special right triangles. The reason why they're special is because they have set angles and a set of rules that relate their side lengths. So given just one of the sides, you can solve for the other two sides by remembering a few simple ratios. So for a 30, 60, 90, those ratios are 2 and radical 3. What this means is that if you're given the shortest side to be x, the hypotenuse is 2 times x, and the longer of the two legs is radical 3 times x. That's it. So going back to our triangle ABD, we're given the hypotenuse to be 12, and we're trying to find the shortest leg. So using our reference, we see that to go from the hypotenuse to the shortest leg, all we need to do is divide by 2. So 12 divided by 2 gives us 6. And we have our answer. The length of side AD is 6. What if the question had instead asked for the length of side BD? Well, we see that BD is the longer of the two legs of this 30, 60, 90 right triangle. So using our reference once again, we see that to go from the shortest side to the longer leg, all we need to do is multiply by radical 3 to get 6 radical 3. The other special right triangle we didn't look at in this problem is the 45, 45, 90. So let's be sure to review that one as well. For a 45, 45, 90, because the two acute angles are congruent, we know that, once again, this is an isosceles triangle. So if one of the legs is x, the other leg is also x. To get to the hypotenuse, all you need to do is take x and multiply by radical 2 to get radical 2x. So the one ratio to remember for this triangle is radical 2. Together, these two triangles are so important that we give them names. This is the 30, 60, 90 right triangle, and this is the 45, 45, 90 right triangle, where the numbers correspond to the angle measurements of those triangles. So I highly encourage you to memorize these triangles and their respective ratios, and be on the lookout for these triangles as you work your way through your own problems.